So I'm going to talk about more about matrix and vector while we are doing the project. So our project is about making a CAPTCHA. So for example, what is CAPTCHA? Let me show you an image of CAPTCHA by Googling here. So CAPTCHA. So if you see the image, so mostly the CAPTCHA images, let's see, CAPTCHA image numbers. Yeah, so I like this one. I think I like this one better. So it's an image of number or character that if human sees it, then it's very clear what it is. But sometimes computer, it's hard to figure it out because computer needs a pattern to find out what that is. But by human brain, it's quite clear. And I think in AI are pretty good job doing figuring out what the number or character is right now. But still, it's so still there are some. It's not 100% correct. So this CAPTCHA is so far very effective to determine whether you are a computer or a person. So they're preventing the automated computerized hacking or abusing of this website. So anyway, we're going to make these kind of CAPTCHA image. So that's our goal. So before we begin, we need to know what the image is about. So you need to know what. So first of all, your end goal is making an image file, right? So you need to understand how to make an image file. What is the image file? So image file basically consists of pixels. So if you see any kind of computer device that visualize anything, then it consists of pixels. For example, your monitor, almost everyone has a monitor. A monitor consists of small light bulbs, for example, that gives the light, and it consists of like a big screen as if it's just a real picture, but it's not real picture. It's just, if you look at closely, it's just the sets of lights emitting from this light source. So let me make an image. Let me show you how to handle an image, and then we're going to discuss how you would plan this project. Okay, so I'm going to make a random picture with this site. So this site basically lets you draw anything on a pixel frame. So I'm going to make a 10 by 10 pixel here. 10 by 10 pixel image. And let's see. Let's try anything like random. I'm just drawing a random thing here. Okay, so here we have some black, maybe yellow, some irregular shape, not symmetric. So sometimes I want to rotate things here. Okay, so this is my 10 by 10 pixel. The rest of the part that I didn't colored is the blank. So it's going to be white if I export this as a file. Let's save it as a file. As a pic here. And let's see, I want to, okay, so I want to upload that file. It's a very tiny file. It's a 10 by 10 pixel. So if you open up in your computer, it will just show a really tiny picture. Where is it? Let me do it again. So I'm uploading my file here. Okay, so now yeah, it's done. So if I open it, then you can see it's tiny, so it's just a dot here. So let's try to open it and then print it out in the Python code. So just to show you what the pixel look like. So I'm going to import, let me make it bigger, import matplotlib. Let's see. Let me change the font here. So how can I change the font? Okay, so 16. Okay, so I think that's better. I think, can I make it? All right. All right. Well, okay. Let's do it this way. So I think that's better. All right, and then so when you want to read an image, then you can use the function called imread. So my file is pic.png in the root folder, and so when you read it, then it returns some data. So let's see what the data is after we print out that image. So if you want to show that data as an image again, then you can use the function called imshow, and let's see what happens here. And you see this is the image I draw. So so these is not XY coordinates, actually. So you can see that the horizontal axis is increasing from left to right, but the vertical axis is actually decreasing when you go up. So actually it starts from 0 to 8 from top to bottom. So what it means is that it's an image in the right, in the correct orientation. So image was this is the right orientation. But in order to put the image in the right orientation, you have to use the index from top to bottom in an increasing order. So here you get 0, 0. Let's say horizontal one is 0, 0. Index is 0, 0. It's white. And 0, 1 is white, and yellow, white, yellow, white. So this is somehow kind of an image of a matrix which stores the information about the color. So let's try to see what really looks like in the data. So I'm going to use the shape parameter of im here. So im is the variable that stores the data of image, and im shape, and I print the im shape, then it stores the shape of this image data, and it shows this 3 numbers as a triple of this thing, like a vector here, 10, 10, 4. So 10, 10 is the width and height. Actually, it's the height and width, which is the number of rows and number of columns. And what does this 4 means? So let me just print out one more thing here. So im 0, 0, then it shows you 0, 0, 0, 0. There are 4 numbers. So this 4 means that at the zeros row and zeros column, there are list of number consists of 4 numbers, which is actually 0, 0, 0, 0. So 0, 0, 0, 0 means that it's white here. It's just white here. And what about this yellow part? So if you want to access this pixel, the one that has the mouse cursor on it, you need to have zeros row, third column. So third column means the index 2. So I need to access 0, 2, right? So now it has a different number than 0. What it means? What does it mean? It has 1.901. So there are 4 numbers. The last one is 1, but the first one is also 1, and the third one is 0. So this number represents the strengths of red, green, blue, RGB. So RGB, and this is alpha. So this is transparency. If it's 1, it's not transparent at all. If it's 0, it's 100% transparent. So red is 1, and you have a strength of green this much, and you have no blue at all. So it seems like it's a random number because it has a lots of decimal. So, but it's really not. What it means is that it's actually in 250 scale. So if you see this way, it actually is an integer. So I multiply this number from 0 to 1 by 255, which means that the maximum number is only 255. And it shows that the strength of this red part is 255, and the green part is 242, and the blue part is 0. So you have red and green to make a yellow, right? Almost red and green, no blue. And the transparency is the maximum. So where this 255 comes from? It comes from the integer from 0 to 255, which consists of first 256 integers. So 8-bit RGB color system. So sometimes RGBA, A for alpha. So that's why we have 4 numbers. So 8-bit means that you have 8 of bits. Bits is either 0 or 1. So what happens when you have 8 bits? You have 8 places to put either 0 or 1. So if you have all 0, that's the binary number 0. And if you have all 1, it's 255. Right? It's 1 less than 256, right? So you can express 256 scale of the strengths of each color R, red for green, red, green, blue, and alpha. So let me show you another interesting thing here. So now this im is, well, why do I have this? So im is actually the NumPy array. It's something that has a matrix. It's like a matrix, but so the matrix of not a number, but of the list of 4 numbers for each column and each row. I want to let's say I want to draw it in an XY plane. Okay, so how do I do that? So if I have this 2-dimensional array. So image is nothing but a matrix of RGB and sometimes A, like this one. And you have matrix, being matrix, here. But if you want to draw something, all you can do is draw a dot or draw a line joining 2 dots. But here in this case, I want to draw a dot. So for example, I want to draw a dot here on the XY plane. But this, let's say this is in the XY plane here. I want to draw this box, this color as a box at X coordinate 0 and Y coordinate, let's say 10, okay? Or maybe 9, because I want to start from 0 in the vertical direction. So I want to draw this box at 0,9. I want to draw this box with a color at 0,8 and so on up to here. I want to draw this box at 0,0. What should I do? I can take each of the point and draw as a dots individually. So that's the one way I can do. So let's do it again. Let's do it that way. So let me increase my horizontal index from 0 to 10. That will actually make my I change it from 0 to 9. And also, so that will be my row index. And And let's say I took J as my horizontal index. Yes, the vertical. So it's so I. So let me make sure that I is the index. So I is the index of row, and J is the index of column. And I want to plot it. Plot I comma J with the color. So how do I know that color? So let's say color is in RGB. So I want to use the RGB color stored in that ith j and j's column of the image data IM here. I think I should make it bigger here. Oh, okay. So here, let me make a bit bigger dots here. So marker size 10. Okay, so it's got a little bit bigger. So here. Okay, so I just plotted my I comma j color at the I comma j xy coordinate plane. Does it seem a bit weird from this picture? Do you think something is weird, something different from this picture, which is the original, and this picture? Yes, what is different? Yeah, the x-axis are different, so somehow it looks like it rotated 90 degrees. But what's wrong in here? Let's find out what's wrong. Why didn't I get the same picture in the same orientation? Yes, row and column is changing. So I put I as an x-axis coordinate and j as a y-axis coordinate, but I is really the index of row. What does index of row gives you about? It's about height, right? If you increase the row index, you get higher and higher, or lower, lower. Anyway, it changes the vertical direction. So I shouldn't be the x coordinates. It should be something about y coordinates, right? So let's do it again. So is this still the same picture? Let me show it in a smaller picture. Is it still the same picture as this one? So it's a better way to put it. Maybe I can put it as a square. Oh, sorry. Now let me put it dot here. So, oh, this is too big. Sorry. I know there's somewhere somewhere I can put it as not a circle but a square, but I forgot. So anyway, is this the same picture as above here? The black one is not on the top, it's on the bottom. So it somehow looks like it's flipped, right? It's kind of flipped. Why is it flipped? What's wrong with this code? Yes, order is different. How do I change it? How do I change I? Yeah, 10 minus I. Yeah, so because it's increasing, not decreasing. So now I get the same picture here, right? So this one only have 100 point to draw. But if you have a larger image with larger pixels, then you cannot use plot for just putting one dot at a time. So it's easier to use scatter. So I'm going to use the scatter here. So plot scatter. I'm not gonna define what xy is right now, but let me just put it here. Marker s equals to maybe 200. Yes. Okay. So when you use scatter, sorry, so it's too small. When you use scatter, you want to put the x-coordinate and y-coordinate of the dots that you want to draw on xy plane at once. So you can plot just one coordinates, like say 0, 0, just one number for each x and y axis. I think let's remove this one here. Here it is scatter. Okay, just one dot here. Okay, so if you just want to draw one dot, you can just put one number for x and one number for y, but you can do it at once. So for example, if I want to draw two dots, 0, 1, and 0, 0 and 1, 0, you can input the list of all x-axis of the dots in the plane and list of all y-axis in the dots on the plane that you want to draw. So here, x-axis are 0, 1, and y-axis are 0 and 0. So now what we want is we need to have a right order, right? So I don't want to throw in x-axis in a random order, because if I do, for example, if I want to, let's say, draw 0, 0 and 1, 2, then I cannot switch the order of y-axis, because if I want the 0, 0, the 0 on the first entry as an x-axis, x-coordinates, has to be matched with the 0 on the list of y-axis here, so that I know that I need to draw 0, 0. And also the 1 on the second entry of the x-coordinates, list of x-coordinates, must be matched with the second entry of the y-coordinates, so that I can draw 1, 2. So what we need is the ordering of the points that we want to draw. So for example, now let's go back to our image. If you want to draw the image, then we need to make an ordering. So in what order do you want to order these pixels? So these are 100, there are 100 boxes here, a pixel. In what order do you want to order it? What's the naive way of ordering these boxes? Well, let's say start from here. Let's say this is the first one, the index 0. You want to go to the right or down? You want to go right? Okay, so let's say go right. So 1 up to 9. And then what's the natural way of next, or what's the natural order? Where's the next box? Second row? Yeah, so this is natural. But you can go like a snake, but it's getting a little bit complicated. There's no pattern. That makes it a little bit harder to make a pattern out of it. So 11 to 19, and so here you get 90 and up to 99. 99 doesn't mean that you have 99 boxes, because we started from 0, there are 100 boxes. So let's use that order. So we're still in the business of making image. So I want to define what x and y is in that order. In that order. So look at the index coordinates of these boxes, the middle, let's say middle point of the box. So the first box is at 0, 9. So x-axis, x-coordinate is 0, and x-coordinate is 1, 9. And what's the x-coordinate of the 10th box? 0 again. So you can imagine that x-axis, x-coordinates of these boxes, which are ordered in this way, will be something like 0, 1 up to 9, and then repeating 0, 1 up to 9. And how many times you repeat this 0 to 9? 10, yes, up to 10. And how about y? So what's the first, the y coordinate of the first box? 9, and the y coordinate is 9, 9, 9, 9, and then the next one is 8, 8, 8, right? So 9, 9, and 8, 8, and the last one is 0, 0. So I want to produce this list, this sequence of lists. Okay, so I have I for I in the range of 10. So that means I get what? 0 to 9, right? 1, 0 to 9. And I want to repeat that again 10 times. So for I in the range of 10. So it's a loop of loop. Let me make it bigger so everyone can see it. So this is one loop. I for I in the range, so you get the 0 to 9. But then you put these whole thing in another loop, the outer loop, which just runs the same thing 10 times. So I don't need an index. You can put an index, but it really doesn't do anything. I just simply want to repeat this thing 10 times. So I put the underscore so that I don't take any number from the range and store it in any variable. So that's my x. And how about y? So we start from 9. So 10 and 9 minus I for I in the range of 10. And for what? Oh, sorry. So this is just repeating. And then I is ranging from 0 to 10. So when it's 0, so you have to go from the outer loop here. When I is equals to 0, then it's just 9 repeating 10 times. And then when I is 1, you get 8 repeating 10 times, and so on, right? So once you have that, now what? Let's try to plot this, scatter x and y. And let's use this. I think there may be because there's no color. So let me put a color here. So, oh, maybe shape parameter. Okay. No, I forgot this. Let me go through this code here again. Marker. So yes, marker. All right. So we got some kind of a dumb image here. So it has no meaning at all. So let me make a size bigger, 100, maybe 300. Okay. So, and also I should make it scaled right. So let me make axes equal each other. So what I did is simply put blue box everywhere from 0 to 9 and 0 to 9, horizontal and vertical. You see what I mean? I didn't do anything. I need to change the color, but I didn't change the color. What I asked this code to do is I simply arranged my points in a sequel and then let it scatter the dots in a square shape at that coordinates with the size of this much. And I got this. And it doesn't really anything to do with the image, right? So if you want to do something about the image, then you have to set the color information here. So I want to set the image color to align with the XY, align with the ordering of the boxes. So image is the two-dimensional data, but what we want is a sequel data in one dimension. Since we order these boxes, image information in one-dimensional array from this way, like this one. So we also need to reshape our image data in one-dimensional array. So there is a, let me make it bigger. So there is a code called reshape in the NumPy array. So let's make it, let me make it visible here. So as I said, originally the IM variable was 10 by 10 by 4, but I want to make it into 100 by 4. So we have 100 columns, 100 rows, and each row consists of 4 columns here. Okay, so then the scatter gives the coloring according to this information, which matches to X and Y. So now let's look at the picture again. Does it same as our original picture? So we got the coloring, I mean, we got the sets of colors right. The white is white and red is red, but something is weird. It's not the same shape, right? Remember this shape, the black one is on the top right, and when we do this, black one is not on the top right, it's on the bottom left. So where do you think something went wrong in this code? Just take a guess. Why didn't we get the same picture? Index for what? X and Y? Yes, that might be the problem. So when we take the reshape of image, we don't know what order they take. We don't know what order does the function reshape to take to change this two-dimensional array into one-dimensional array, right? It has its own way of reordering these boxes. So the actual, I mean, if you don't have any attributes here, then the default way of ordering this two-dimensional array to reshape into one-dimensional array is that it's not going horizontally first, it goes vertically first. Okay, so that's an example. Let's try to do it this way. So if you order these boxes horizontally first, then this is the right list of x coordinates and y coordinates. But how about if we take this ordering first? So this is 0, 1, 2, 3, 9, and 10, 11, and so on. So then what will be your list of x? So x is now not changing at all, right? 9 minus I, right? And then your row is now changing, and the y is changing from what? Oh, sorry, it's just I. Y is changing from what? When you move from top to bottom in the first 10 boxes, your y coordinate is changing from 9 to 0, right? So it's 9 minus I for I in the range 10, and you repeat that 10 times. So now you get the right order, right orientation of your image. So this is very important part if you want to manipulate your image, because everything is in the pixel. If you want to distort or move, like you want to translate your image into different place in a big canvas file, then you need to have a coordinate to move their coordinates, right? So originally the image was just simply a data in a matrix form, which only has a row and column, but now we change this image data into some kind of points in XY plane, right? So and then every point, let's say what I'm saying by point is one box here. Let's say this box. I think this box is at the 2, 6, And this box, if you consider this as a point, can be considered as a vector, endpoint of a vector from the origin to here, right? So now if you want to change the position, you can add a vector, another vector to this vector, and then move this point to another place. So now you can change your shape or position of your image in XY plane, okay? So let me say it again. Image is just a two-dimensional array of data of a color, but if you want to manipulate that image, then you have to translate that information into an information on XY plane. That's what we did so far. Okay? So now let's think about, I'll give you time to think about how to make a captcha here. So let me give a big steps here. So if you want to make a captcha, you need to think about the final end product here. So image of captcha is here. Well, let's not consider about image size of image or anything else. I just want what's inside the image. First of all, I need a list of character. So I need to know what character are in the captcha in order to find the captcha, right? That's the most fundamental thing you have to first think about. And then from here to here, there are lots of things to consider. If you just put your list of character as a string and put it in the image, I think that's not going to help to distinguish whether you are a computer or a human. So you have to do something to confuse computer to distinguish its character. So computer is really good at distinguishing character. Like if you go through like a toll gate, they can automatically distinguish what the letters on your license plate, right? So you want to do something to manipulate the image of each character to confuse the computer. So some kind of manipulation of image of character. And then after this, you have to go through here. So there are many steps that you have to think about from each these milestones here. So this is not the end goal. I mean, you have to find out way to go from here to here and here to here. You just don't, it doesn't magically happens. So first of all, if you have a list of character, you have to think about how do you store that information that contains the list of character in the Python code, and how you're going to manipulate, or at least in the first place, how we're going to manipulate each of these character and then store that information in another variable. And the manipulation, the way of manipulation itself has something you have to consider again. And then once you manipulate, once you distort that image of each character, how are you going to combine them together into an image of captcha? So we're going to go through all the detail of the Python code, but think about idea of how you're going to first put the list of character and then manipulation of individual character. What kind of manipulation are you thinking about? What kind of thing that you think that it will confuse the computer? And then think about how you're going to put everything into the image of one image of captcha. So I'll give you time to discuss with your group members just the thing about these 3 steps. And then if you're also confused about what it means, then you can also discuss with your group members. So how about, so Kim Seung-yeon, so what did you discuss about these steps?
We discussed about how to make captcha image to just number to a image that computer can't understand easily. And
yeah, that's the idea of a captcha. But how do you think that you will manipulate the image of each character?
we discussed about 3 methods of make the number to a captcha. That is making a lot of image of the number to 0 to 9 and changing axis to -45 to +45 and making
You mean rotating
other
axis?
yes,
Okay.
rotating axis and making different color by Python code.
Okay, so you want to change the color and have some rotation of image of each character. Number character, okay. So, okay, anyone else want to share your idea about manipulation? Yeah.
Right, so our idea is, first of all, we know there's a random function and random module in Python. So using that, we will select all, like we'll make this list of characters, numbers, and colors, different variables, and we'll select random from that. Then we'll make an image, and then we'll put it in Jacobian matrix. I'm not sure about that, somebody knows it. From that, we will change the linear image into slightly
deformed image. Okay, so you want to change you want to deform the image by matrix. So he mentioned Jacobian, but I will change it to matrix simply. Okay. So anyone else? All right. So let's talk about deformation. So people talk about the rotation. That's one way to deform it. What other ways do you think about the deformation? How can you deform an image other than rotation? Anyone else discuss about different ways of deforming the image other than rotation? Yes.
So I was in the same group with them. We kind of discussed to make a different handwritten version of for each number.
Okay.
Actually, write one in a different ways, right?
Okay. So you can manually create an image of the character. It's kind of deformation. Yes. So yeah, that's one way. Okay, that's what you meant by creating lots of image of the numbers. I didn't understand what it really means, but now I understand. So anyone else has thought of other ways of deformation? There's no answer to this. So, but even if you have handwritten image of the characters, you can make infinitely many, right? You have to deform it again. You have to further deform your handwritten image of characters to make a variation of your handwritten data, right?
Drawing lines on characters.
So yeah, that one is the good deformation. I already showed you, or you've probably seen that kind of deformation in the character. So that try to make it confused. Yeah. So so let's think about. So what do you need before you take a deformation or manipulation or distortion? You have to take an image of your character first, right? Well, you can have an image of character by writing manually, but let's say I have a standard image of one character each. How do you make that? So so just have a list and you take each character of the list and then take the image of a single character, and then you have to manipulate somehow, right? That's the natural way of thinking. So let's let's try to take that one image of one character. Let's say I want to take 6. Okay? So character is just the variable that's storing that one character. And I want to transform this information 6 into an image. So I need to plot this image. So this 6 is nothing but just the text, right? So PLT text has a way of drawing the text. So the first 2 is the coordinate of the character that we're going to put it in XY plane, and the third one is the actual string that you're going to draw in XY plane. And then there are some attributes you want to put in because of so size. I think it's just size. Font size, sorry. So font size. It should be very big. And some other attribute is that you want to make your string or character, put it in the middle of the point that designated here, the 0,0. So you want the center, horizontal center, and the vertical center. So just for your information, when I change the line, it's only for putting everything as much as possible in the left-hand side. So you don't have to break the line. You don't have to always break the line. But if you break the line, then it makes it more easier to read the code. So and then, okay, so let's just show what happens. So you can see that 6 is drawn in the 0,0, but it's not really the image that I want. I don't want the axis box. I don't want the box. I don't want the number. I just want the image of 6, right? So I just want to get rid of all the other thing except the number 6. So let's put more attributes here before I plot this. So axis is going to be off. That means disappear. And I'm going to equalize x. So not equals. Equal doesn't mean anything here. I want to make it tight. So tight means that it's tight around the whatever is shown on the x-axis. So axes are gone. So it's tight, but image is quite big. There are lots of white boxes, but that's okay because we're gonna do something about this image because now it's only 0 and only the black and white. So I can just distinguish easily which one is white and which one is black. So that's okay. But this is just an image. It's shown on the screen. I want it as a data. So in order to have a data, I need to save it as a file, right? So save as character 6 as a PNG. If you want the white box, the white thing around this character even smaller, then there is another attribute you can put, like bbox inches to be tight, then it make it a bit tighter. But the white box, it really doesn't disappear at all. So anyway, once you save it, then you can see that it's a new function, new file is saved here. So you can see you cannot see the boundary of a picture, but this picture is this much big, and you can see all the white blanks around this number 6. And I can do it for all the characters, but let's just stop it here for just 6. And let's try to manipulate this image. What can we do? Well, let's talk about the rotation since there was an idea of rotation before. So here, let me define the rotation matrix and then see what happens. So let's say R theta is 2 by 2 matrix given by cosine theta, sine theta, sine theta, and cosine theta. So this is called the rotation matrix. So what it do is that if I multiply this to xy And I mentioned about the matrix multiplication. What's the size of the matrix? This is 2 by 2, this is 2 by 1. So the size of a matrix multiplication is 2 by 1 again. So it sends 2 by 1 to 2 by 1. So let's say the coordinates of x of this 2 by 1 matrix as x prime and y prime. So the relationship between this xy and x prime y prime is that the x prime y prime vector, let's say this x prime y primes are coordinates of two-dimensional vector, is theta degree rotation of the vector x comma y counterclockwise. So that's a theorem and definition. So how about the size? Well, the size are the same. So the size of x prime y prime vector is same as the size of original vector. So you can see that what the matrix really does to a vector is that it transforms the vector. So we have 2 by 2 matrix and 2 by 1 matrix. This 2 by 1 matrix coming from actually the information about the vector. And this 2 by 2 matrix is changing one vector to another. And this special one is actually do something geometric, which is rotating. And what rotation means that you have a pivot. You need to have a pivot to rotate something. So this pivot is the origin. So if you have the vector represented as an arrow whose starting point is the origin, then when you take the rotation, then you get another vector x prime y prime. And to rotate by theta degree, you need to multiply this r theta this way. It's counterclockwise. So you want to see whether this actually happens in this picture. So let's say we want to rotate this 6 by 45 degree counterclockwise. So what do we need? So first of all, I need to know, I need to figure out all the points which consist of this pixel in this image as a vector, right? The same way we did in the picture I showed you before, 10 by 10. Here we have lots of pixels. For example, how many pixels do we have? So let's say, let's read this image file, imread, and character 6, PNG, and let's print out the size of this image. So 389 times 555. So 389 rows and 515 columns. That's why it's wider than the horizontal axis. So if you multiply these two, that's quite big. So anyway, that's this the size of the image. And what we need to do is the same thing we did for 10 by 10 image. We want to take the x and y coordinates as a one-dimensional array for each pixel, and then make it into list of xy coordinates. So first of all, let's do this. So we have shape means height and width. So I'm going to store the 389 to H and 515 to W. So again, this 389 and 515 is the number of rows and columns. So number of row is the number of the height, and number of column is the width. Don't confuse with this. So X is what? Let's take natural order. So vertical order. So first, so it's increase. So index of the one-dimensional array after rearrangement increase from the top to bottom and then move to the left to right. So the x coordinates are going to be same thing every time unless you change the column. So I for in the range of height, right? For I in the range of width. Okay. And y is now a different story. So be careful that you have to decrease the order, right? So we have height minus of I for I in the range of height for, repeat everything for the width, okay? Let me close this out, and this x and y. And then what I'm going to do is, that's okay, so that's, for now, that's okay. Let's see whether this works. So I'm going to use the scatter, x and y. And I'm going to set the color to be image of the reshape, fh, the width and height times 4, and see what happens. Oh, I think it's a small dot, very small dot. Let's see. While we're waiting, even if it's small, there are lots of pixels, so it's actually drawn correctly here. So you see, there's a bit wiggling here. The reason why it's wiggling is because every single pixel we draw dots. So it's a dot is a circular dot. So that's why I have a slight wiggling here. So if you make the size of this dot smaller, then you will get a sharper and sharper image, but not as sharp as the original image as a pixel. So anyway, you got this. So the thing is, it's not this image that is important, because image can be always wiggling because we are going to make a CAPTCHA. The important thing is we translate the image data into XY coordinate data. And so we want to manipulate this data, image, right? So let's try to make a two-dimensional array of XY coordinates out of this x and y. So let me, so I first need to import the NumPy here. Import NumPy as NumPy. And then I'm going to save the NumPy array whose first row is x and second row is y as xy. And what I'm doing here is we have a list of all the numbers of x coordinate, y coordinate, but I want to put that into a two-dimensional array. So let's say I gave an index of all the points on the pixel from 0 to the total number of index. So the x coordinate of the first point in the image is x0. First y coordinate is y0, and so on. So it's quite large, like say big number n, and y as big number n. So this is 2 times n, where n is the number of pixels in the image. So I'm doing this. I'm making this 2 by n matrix. And what I'm going to do is multiply a matrix on this big matrix. So what it is r theta times xy. So this is cosine minus sine, sine cosine times x0, y0 up to xn, yn. So actually this is xn minus 1, yn minus 1. To be precise, okay. So you can carry out this computation because the first matrix is 2 by 2 and second matrix 2 by n. These twos are the same, so multiplication is possible. So let's say I got, what do we get after this multiplication? 2 by n, right? So let's say the entries of the 2 by n matrix is x0 prime and y0 prime, and xn minus 1 prime and yn minus 1 prime. So let's think about one by one. How do you obtain this x0 prime, y0 prime? You obtain this by multiplying. First, x0 prime comes from first row, first column, right? These two. And how about y0 prime? It's obtained by taking second row, first column. So this is nothing but multiplying the rotation matrix times 2 by 1 matrix, x0, y0, right? So if you take this first column of the result, then this is the rotation of the vector whose coordinates are x0 and y0 by theta degree counterclockwise, right? So if you take all the vector coordinates for each column, the resulting vector matrix has column entries which are the rotated vector by same angle given in the rotation matrix. So we don't have to rotate each point at a time. We can rotate at once by multiplying this 2 by 2 matrix into this xy matrix. So let's first define my rotation matrix. The rotation matrix you can define by def or lambda. I will use lambda here. Is another 2 by 2 matrix. So the first one is cosine, and the second one is minus sine. And the second row is sine and cosine. So R, sorry, just R. And let's rotate. The new xy is R 45 degree, right? So it's pi over 4 at xy. So at is the matrix multiplication between two numpy array, two-dimensional numpy array. And instead of putting xy, which is the first and second row of xy matrix, I'm going to put the first and second row of new xy. So first row and second column, second row, sorry. All right. It takes a little bit of time because it's quite big. So, okay. See what happens here? So let me make axis equal. So let's make axis equal here. Takes another long time. So basically, I think the scatter function takes the most of the time. So I will give you ways to make it shorter. So now you can see that the size is not really changed. I mean, the ratio, the horizontal and vertical ratio of this image is not changed. It only rotated. That's what I meant when you multiply the rotation matrix, the size of a vector doesn't change. Okay. Actually, it's interesting that you see the coordinate where the 6 is lying in. Where does it lying in? So it's lying in somewhere between somewhere at the 0, 300, right? If you look, if you remember how we draw this 6, it was actually sitting on the 0, 0. But now it's kind of hovering above the 0 here, right? So this is the x coordinates, x-axis. It's way above this x-axis. So, but I kind of want to take this 6 into 0, 0. I want to have a center at 0, 0 and just rotate with the same center. So how do I do that? I don't want this 6 to be like move around this 0, 0. I just have a pivot at 0, 0. What do you think I should do here? So let me show you with an axis. So let me get rid of this axis. No, actually, let's simply draw this scatter point. So we have scatter. So we have scatter and x, y. Let's see what happens here. Let me see the axis. Let me see if I can see the axis here. Oh, yeah, I think I should just keep this axis off, and then let's see another one. So let me make it smaller. Okay, so where is my 6? So my 6 is actually around, let's see, between 230. I mean, the middle of this 6 is around 200, between 200 and 300, and then 200 y-axis. And when I did 45-degree rotation, what I get is 6 is above this 0 axis here. You see what I mean? I didn't have a pivot at 0, 0, right? So it's somehow, from the original picture here, I rotate and then move this 6 to around here, right? Why did it happen here? What happened here? Why did I move my position of 6 instead of having just rotated at the same place?
Center of rotation.
Mm-hmm.
Origin.
Yes, center of the origin. Center of the rotation is origin, and yeah. Yes, yes. So now I didn't really rotate it only the black dots in the 6. I rotated everything. So this white thing is the point. There is a point on every part of this screen, and every dot, every pixel is considered as a vector from origin to that place. So I took each of the vectors and then rotate 45 degrees. So in a sense, I didn't rotate this one. I rotated this much, all the points in this big box at the center of origin here. So that's why I get this whole rectangle rotated at 0, 0. That's why my 6 is moved above here. So you can see the imaginary line is drawn in here. It's rotated this much, right? So how do I fix it? I just want to rotate 6. And I want to keep the center of 6 the same as before after rotation. How do I do that?
You can go to the image and like detect the colors like black and
Uh-huh. Yes. Only the black part rotate. Yeah, but even if you black part rotate here, this is after. Even if you take only the black parts, this vector from here to here will rotate. That vector rotates. The 6 will be placed different. Yeah.
Find like height and width of black color as it said earlier, and maybe in code we can get in. I think we need to find the H and W.
Yes.
Only to our.
Only here.
Yeah.
H and W only here.
And work uses many.
Yeah, that one could work. Like you want to get rid of all these parts, but still, if your origin is here, then it will like move this much. But I want to keep the center of 6 and then move here. But you're talking if I crop the image this small, then it will kind of, yeah, of course, it will not move that much, but still it's kind of pivot around here, not here. So I set my 6 at the center of image. I simply want the pivot to be center. So pivot is always origin. So the way I can make the pivot to be center is make center to be origin, right? How do I make center to lie on the origin? So center is around here. I just simply shift, right? Shift all the x and y axis at the same amount, right? So let's draw this. So here, instead of having x as just I, which is the index of row and column, I want to take away the half of the width, right? So then I can move to the left by half of the width. And from y-axis, I move half of the height. So if I take away half, it's just same as half of h minus I. So let's draw this again. Now where is 6? You see where the 6 is. It's right at the center of origin. Center is at the origin. Now let's rotate again. So here, I have to change this again. So W over 2, H over 2. And then if I rotate, then I get the same place, 0, 0, right? Now let's be a little bit clever. So we know that we don't need to take white part, and also we shouldn't take the white part because later we're going to overlap these numbers together. If we carry the white part together, then whatever we overlap will overlap entire image, right? Lot bigger part of the image. So if you just want to overlap the image part, then you have to get rid of the white part. So how do we do that? So it's about just coloring part. And also you need to take only the certain column of your XY or new XY, but you can work on with XY part. So which column, how do you know which column you should take and which column you should discard? So in a sense, this contains every pixel, but you have to decide which column is about the white pixel and which column is the black. So here, let's take the black part, and I'm going to take the index of the black parts by the following code. So let me make it bigger. So black part is where if I iterate over this image data, the image data, so here, I didn't put just the image because then I just iterate over the rows. I'm taking enumerate. So I take I as an index of row and V as that row. So V is the information about the color at that ith place in pixel. So if that color information, RGB data, if I multiply all the numbers in that list, which is 4 numbers basically, is bigger or less than 1.0, then I consider it to be white, because white was 0, 0, 0, 0 actually, but there's only white and black. Black is 1, 1, 1, 1, 1. Okay, so unless I have all the entries of the color information is 1, I consider it to be discarded. So that's the black. That's where I consider where the black color is. So that's the list of index where the black color is. So I only take where the black is. So I take all the row, which is x and y coordinates, right? But I only take, sorry, not I, the index where the blacks are. Right, so and then xy and then new xy and then now we have a scatter. So so I need to take this one also. We have I im new im is, so I should take, oh I need to do this. So sorry. So I have to reshape im here. So after reshape, I go through finding the index where the black pixel is, and then I only take the pixel coordinates where the black color is, and I set the color only with black. All right, only black. All right. Or I don't really need this because it's always black, so I can just take K here. Sorry. Easier this way. It's getting easier, a lot easier. I mean, the reason why it's big, it's not really big. It's not because it's really big. It's just because the x's are getting smaller. So you can see that it's only go up to 60 and so on. So still, you get the same 45-degree rotated picture 6. Now, okay, you can do more. You can throw in lines, whatever. But let's skip to the important part. So if you have just one character, it's not powerful enough. You need several characters put it together in a single image to get the capture, right? So how do you get the several character in a one single file, image file? So you did this for every character from 0 to 9, okay? So let's try to generate all the image. So I'm going to change my code that I made previously here. So I did for character 6, but I can do it for I in the range of 10 from 0 to 9. And okay, put it in the character. So now convert my integer I into string number, a string variable by stri here. So it becomes a string. And then I do the same thing, font size 100, 00, axis up, height. And then I want to save it to a different file for each different number here. So, okay, so here, there's many ways you can do it. So one way I can do this is, let's see, F. Yes. So if I do this, then my string contains a variable which stores the information about the index here. So according to that number, it will convert to string, and then it will become the name of the file. So let's run this. Oh, okay. So before I run this, I have to make sure, because it's iteration, I need to CLA, I think. Yes, let's check. Okay, so when I run this, so axis of, axis type that are explained already. So save fig in a different file name. The CLA is what it does is it clears the window. It clears the image window. So if you don't clear the image window, is that what happens is that you take an overlap. You keep drawing an image on top of the previous image. So you're not gonna get the single character, single text, but you're gonna the overlapping image. So let me show you what happens if you don't have this. So then you see what I mean. So first, where is character 0? Character 0, it's 0, but character 1, it's overlapping of 0 and 1 because you didn't clear the previous image of 0. So 1 is drawn on top of 0, and 2 is top up on that, and so on. So it's not gonna do any good for us. So CLA is required here. Okay, so now you see the clear 2, 0, 1 is here. Okay, so now we have all the information. Now let's try to manipulate a little bit. we don't have much time, so I'm gonna go a little bit faster here. So now, if you want to make a CAPTCHA, you need to have an answer for yourself. So CAPTCHA, let's take a CAPTCHA as 1, 2, 3, 4. That's my answer. And for C in the CAPTCHA, so I want to do it for every character, every single character here. So when I do this, I go through 1, 2, 3, 4 character. It stores in the variable C, and then do the rest iteration. And then I do the same thing here, almost same thing. Put it in the for loop. Read this file, right? C. Sorry. So read this file. C. So here C is not a number, it's a character. So I need to put the character inside my character. So that's why I put the percentage S here. So it will be replaced, but whatever stored in this C here. Let me put it bigger here so I can see it. Now I do the same thing, almost same thing here. So I don't need to draw it again. So not drawing. And let's see. So I don't need this. I don't need this. It's the same thing. It's okay. So let's put the import numpy. Sorry. Just delete all this and import numpy on the other line, the first line here. And then, okay, so numpy array stored in XY and reshape, yes. And then take a black parts only, and then take the black parts index only, and then I can take away this R parts out of this for loop because I don't have to define it every time. And then, yeah, so now rotate part. So rotate, if I take this constant pi over 4, every character will be rotated in the same amount, but I want some randomness here, so I'm going to import the random here, import random. And let's say theta is my degree of rotation. I want it to be any number between minus pi over 4 to pi over 4, minus 45 degree to 45 degree. And there is a random function in the random package called random, so it's the same name as a package. It only gives you the value between 0 and 1, random value between 0 and 1. So if you want to convert it to the random number from minus pi over 4 to pi over 4, then you have to scale it. So it's starting from minus pi over 4 plus pi over 2 times the random number. Then you can see if random number is 0, then you get minus pi over 4. If random number is 1, then you get pi over 4. So you get the random number between these two numbers. So anyway, so let's put that theta over here. And then what you do is you want to scatter plot this number, which is now rotated a little bit. And you want to make it equal axis. Okay, so that's okay. So now let's, I think it's not, so this is not the complete code, but let's see what happens. So you can see, what do you see? 1, 2, 3, 4, 4 numbers are overlapped all together. So even human cannot distinguish what number is, and you don't have an order, because if you want to type in a number, then it somehow conveys what order these characters are listed in the image. This one, you cannot know what the answer is. So what's the problem? How can you how can you just put the number in a sequential order from left to right? So what we did is just rotating the number, image of number, and then putting in the 0, 0 center, right? So every time you put the next number, you want to move it to horizontally to the right, right? Right. So you have to translate. So the new xy has to be translated again. So new xy has to be added. So now the translation is only for x-axis, right? So your x-axis has to be added. Your x-coordinates of every point has to be added to the same amount. So you want to add a vector with same numbers on the x-axis. Here. So I want to add something that certain amount x, let's say x off here, x off of the same x off here, and 0 and 0 in here. So I want this, I want to make this matrix. Okay, so how do I do that? So here, I'm going to set my x off to be 0 in the beginning. And I'm going to increase my x off by maybe 20 every time I draw another character. And let's see, x off for I in the range of length of whatever, black, 0, or let's say black, or length of black, right? So length of black is a number of lists of the index where the pixels are 0. So I need just the number of columns to be that much. And the next column is the rows of zeros, and the number is same as the black here. And then NumPy array, I forgot the, yes, okay, so we have here, and let's see. Okay, so it's a bit, separated apart, but not that much, so human cannot understand what it means still. So let's make it a little bit larger. Yeah, so now it's somehow understandable, right? Human can know it, but if you put that in the ChatGPT as an image to tell what the number is, what the character is, maybe they can't tell, maybe, right? So you can work with any numbers, actually any character. So let's say random number with 6 digits. So we'll have a 6 digits. I can kind of tell what that is, 359,610, something like that. But I think if you try by yourself and put it in an AI machine, I think it's really hard to tell. And let's work in the character, like A, B, C here. Oh, there's no A, B, C, sorry. So that's why it doesn't work. So, okay, so sorry for that. So if you have an A to Z image, then it also works. Anyway, so that's one way you can make CAPTCHA.